Okay, this is going to be the Algebra 1 Unit 1 review for 2019-2020. Some of you guys have more up-to-date Casios. You're going to be able to use different features than I have in my emulator. First simple one, evaluate each expression. Okay, so what I'm just going to do, I'm going to do 4 exponent 3. Yours should pop up. Okay, divided by parentheses 28 divided by 7 minus 9. Okay, so that answer is 7. Okay, this one, what you're going to want to do, your calculator will have nice prints. When you hit this ABC button, you should get the fraction. For me, what I'm going to have to do is use parentheses, so 10, all right, parentheses 5, all right, minus 8, close them, divided by the lower part, which is 35 divided by 5. Okay, you guys will be able to use the ABC button. Okay, answer is 6. Okay, write the expression as an algebraic 12 times the square of a number. Okay, so the number right here, that's going to be our variable. Okay, so 12 times, okay, the square of a number. So 12 times, okay, you can just rewrite this x squared. We can imply that there's multiplication between that. Jim has $7 less than 4 times the amount Sarah has. Okay, now this is where it sort of gets confusing. Okay, this 7 less will always be after in this case. So 7 less. So 4 times would be 4 multiplication. So I'll use 4n, doesn't matter. Okay, that's how you would write 7 less than 4 times the amount. The square of Sam's age minus twice Heather's age. Okay, so the square of Sam's age is twice minus twice Sarah's age. So the square of Sam's age, we can use x or n, minus twice Heather's age. Okay? The quotient of the cube root of a number and 8. Okay? The quotient means division. The quotient of the cube root of a number and 8. Okay? So you can do this a couple different ways. You can do it as a division symbol. All right? The quotient of the cube root of a number and 8. Okay? All right? Okay, let me just scroll a little bit here. All right, write the expression as a verb, the algebraic expression is verbal. Okay, so this would be 10 less than 4 times a number. Number n. Okay? This would be the cube root, or I'm sorry, z minus the cube root of the product of 5 and y. Okay? Okay. This one right here would be 6 less than the square of 2 times m. And there's a lot of different applications of what you can do with this. It doesn't have to be perfect, but you have to be able to convert minuses, less, or minus, or more. All right. This would be the quotient of 6 times a number, 6 times a, and b. Okay? All right, make sure you can still see that. Yep. Evaluate each expression. So what I want to do when I do the evaluation tool, make sure you can still see that. Yep. I want to substitute this value for x. So -8 arrow for x. And then I just type this in just like I see it. 647. Okay. This one I want to store A and I want to store B. So 6 arrow, whoops, alpha. So you hit this little red button then here, alpha A, execute. Then -2 arrow, alpha B, execute. Then I got 8 minus 4 alpha A divided by, all right, parentheses, absolute value. I get there by option, calc, oops, I'm sorry, option scroll, I think actually, I'm sorry, option scroll, num, absolute value, okay? All right, once again, your absolute value pops up better than mine. Alpha B plus 2, close it again. Once again, yours will pop up with the pretty print. Okay, now that's that number. If you hit the fraction to decimal, you get yourself a fraction of -8/9. Okay, we're going to store 216 and we're going to store 36. Arrow, alpha M would be here. Execute. 36, arrow, alpha N. Execute. Cube root. Okay, cube root's located right there, so I hit shift in that. Alpha M plus 6. Shift, square root, alpha N. Alright, answer is 42. Okay, we're going to store 4 for H and 6 for K. 4 arrow alpha H. Okay, 6 arrow alpha K. Okay, 5 parentheses alpha H minus 2 plus a half, which you could use the fraction button for. Okay, all right. Then 26 plus alpha K. 26 would be the answer. Okay. All right, now this next one, this is going to be, let me just go to blue, just to like blue a little bit better. Okay, you want to combine your like terms. So this term and this term are alike. So what you have to do, very important, okay, you type them in. Don't change the exponents. Okay, very important. So what I would do is 10 minus 3. And then what that becomes is that becomes 7f. Then I would do -2 and -15. -2 minus 15, -17g squared. Okay? This we have to multiply. So 8 times 10 would be 80. 8 times x would be 8x. Then I take this and I multiply. 2 times 5x would be 10x. 2 times -3 would be -6. Now, what I want to do is group the like ones. Okay? So 8 and 10. Okay, then I'm going to group 80 and minus 6. Okay, so I got 18x plus 74. Okay, my like terms here are 7a, this, okay, this one, the 12b, and the 4b, and then that one will stand alone by itself. So that'll be 7 plus 1. So all we do is we look at the numbers out in front. 7 plus 1 would give me 8a, 12b plus 4b is 16b. And then I got minus 11 all by itself, so I'll keep the minus 11 there. Okay? Like terms here, I got this, okay? All right, the other one I got is I have this one. This one looks close, but it's not quite the same, okay? So I want to do 10 minus 4, which would be 6m to the 4th. Then I got negative 2 minus 3 is negative 5 m squared n. Okay. Oh, whoops, I did something wrong here. No, I didn't. No, I'm good. Yep, I'm fine. And I got this standalone at 11 m n squared. Okay. Let me make sure that I got all the problems. Oh, I got this page. I got my inverse. This is something you got to sort of know. The words sort of give this away. Okay, all right. Multiplicative inverse means multiply. Okay, this would be considered an inverse, so that would be B here. The commutative property is the order. The associative property is the parentheses. So the order not mattering. So the commutative property, as you can see, that would be that one. The order not mattering with the parentheses shifting, that would be this one. All right. Multiplicative property of 0. So once again, multiplication, that would be G. All right. So multiplicative means multiplication. So that's a dead giveaway on those. Reflexive property, I'll leave that to the end. Okay. Transitive property, the way I think of that is like a train. Okay, and what that means is you connect A to B, B to C, and then A connects to C. So as you see here, A to B, B to, and then these two connect. So that's why this one here is the transitive property. Okay, additive identity. Once again, additive means plus. So if you look at the identity, identity means self. So that's why this one is A. The distributive property. Pretty simple. I think everybody knows the distributive properties. When you multiply those, that would be C. So that leaves this for the inverse. Reflexive property is almost like reflection. Okay. All right. Think of like self. Okay. Another deal there. Okay. So that's right there would be the properties. All right. All right. Now, so the graph will illustrate the relationship between time, distance, described in words. What's happening? This right here, all right, what would happen there is, all right, distance. So this part right here would be distance increased with time. All right, this would be, this part right here would be distance decreased with time. And this right here will be distance is constant with time. Okay? So constant means it's flat, distant, decrease is going down, increase obviously going up. Okay? What is the range of the function? Okay? When the domain is this. So these, domain means x values. So these values are going in for x. So the way I would handle this to make this easy on myself, what I would do is I would do negative 5 arrow x. So it's like a substitution problem. 10 minus 3x. Okay, so the first one we get is 25. Then I would put 1 in. Gives me 7. And then I would put 6 in. -8. So that right there is the range. These are the y values, okay? If the vertical line passes through more than one point of the graph, the relation is not a function, okay? So the idea with the vertical line test of any function, if you draw it and it passes through more than once, okay, it's not a function, all right? Okay. All right. It says, which of the following, write a value that would result in the following being a function. So the only thing we need, here's another thing that you have, is x's, repeat, no function. Okay? So obviously, we got it wants it to be a function. So in order for it to, if it's not a function, then the x's would have to repeat. So I could pick any x here. Let's say I pick 7. Okay? That's different, so I'd be good. Okay? So what we treat these mappings like, this would be x, this would be y, this would be x, this would be y, this would be x, this would be y, x and y. Now, some people find this easier to do, okay? Which, like, I think sometimes doing this, all right? What this means is 1's going to go to 3. 1's going to go to 3. 3's going to go to 3. And 3's going to go to 6. Well, as you can see, the x's repeat. So this is not a function, okay? 1 goes to 3. 1 goes to 5. 4 goes to 5. Since you got 1 and 1, that's also not a function. Okay? All right? All right? This 1 goes to 6. Okay? All right, 3 goes to 3. 3 goes to 5. 3 goes to 6. 4 goes to 3. Once again, this one is not a function. Okay? And then this last one. 1 goes to 3. 1 goes to 5. Okay? 3 goes to 3. 3 goes to 5. So this is also not. So sort of a trick question. They all were not functions. What you're looking for is if any of the x's repeat, the answer is not. Okay, which is the independent variable? So, the dependent. So this line always right here is the dependent. And the independent variable, I'm sorry, we got that backwards. Hold on. Okay, the independent variable is always the x, and the dependent is always the y. Okay? So in this case, the dependent variable is actually temperature. Okay? What is the ordered point at A, and what does it represent? Okay? The ordered pair is 681. And what that means is at 6 a.m., it's 81 degrees. Okay? Which statement responds to the graph? We talked about this earlier. This means that it's constant, that basically the price is constant with time. Okay? So the price of the constant didn't increase, it did not change. Okay? That's also another way of saying constant. Okay? Use the graph at the right for the next two questions. Okay? What is the range of the relation? What you have to do is you really have to come up with the ordered pair. Now, this is a little hard to see, so I'm going to do this like this. So this is, oh, it's terrible. Hold on. Okay, so this point here is 1 over 2 up. This point is 1 over 4 up. Okay, all right. This point here is negative 1 over 4 up. This is negative 2, 0. This is negative 1, 1, 2, 3, 4 is negative 4. and then 1, 2, 3, 4, negative 4, negative 1. Okay? So range means y values, so my y values are negative 4, negative 1, 0, 2, and 4. So the answer would be A. All right? What can be said about the relation? Okay? All right? So if you look at this, I've got multiple x values that are the same. So this should be not. Okay? All right? The relation is not a function. Which of the following is a function? Okay? Vertical line test. If I do this all the way across, it only passes once, so that's yes. The x's do not repeat. So this answer is yes as well. Okay? This one, as you can see, if I were to write these out, it's like negative 4, 0, negative 3, 2, negative 3, 9. So every time the line goes from this, that equals one thing. Then 5, 9. So what ends up happening because we got negative 3, that answer is not. Okay? This one here, I'd be at negative 4, 0, negative 3, 9, 8, 9, 5, 2. This answer is yes, because all of those are different. Okay. And let's see if there's any others. Nope, that's it. So that's your first Algebra 1 video. If you prep for that, you should do well in the test.